So now let's look at a combination circuit. What if it's not just series and not just parallel? Because this is what most circuits are actually constructed like. So in this picture, we have three capacitors and we have to ask how are they connected. So we remember series is all in a line and parallel is top to top, bottom to bottom. As I look through this circuit, I don't have anything in this one that's all in a line. There are none that are plainly in series. C1 and C2, they are connected by their tops and they're connected by their bottoms. So what this tells us is that C1 and C2, these are connected in parallel. So my first step in finding an equivalent capacitance is to pick the ones I can tell and do an equivalent of those. It's a step-by-step process. So let's do an equivalent where I take C1 and C2 in parallel. That's going to bring me to a new diagram. I remove C1 and C2. I put in a new capacitor. I'll call it C12. I still have my C3. And this is what the new circuit looks like. I'd like to find the value of C12. I remember that when capacitors are connected in parallel, we add up the capacitances. So C12 is equal to C1 plus C2, 4 microfarads plus 12 microfarads to give me 16 microfarads. All right, for my next step, I have to look for my next connection. If I look at C12 and C3, I see that they are all in a line. These two are in series, so I'm going to do a new equivalent circuit where I treat those in series. So here's my circuit. I have C12, C3. These capacitors are in series. So I'm going to draw a new equivalent circuit. That's going to have my battery here, and it's going to have my equivalent resistance right here. C equivalent. My battery has potential delta V equals 12 volts. When I have capacitors in series, I remember that 1 over C equivalent is 1 over the first capacitor, I labeled that C12, plus 1 over the second capacitor, which is C3. So that's 1 over 16 microfarads, plus 1 over 2 microfarads. When I add those together, I get 9 over 16 microfarads, because 1 over 2 is the same as 8 over 16. 9 over 16 microfarads, which tells me that my equivalent capacitance is equal to 16 microfarads divided by 9, which is 1.78 microfarads. So my equivalent capacitance of the entire circuit is 1.78 microfarads, or 1.78 times 10 to the minus 6 farads. So 1.78 microfarads. Okay, that's the first question done. Find the equivalent capacitance. Next, we want to find the charge on and the potential across each capacitor if delta V equals 12 volts. What we're going to do now is we're going to start to work backwards. Here's the idea. I'm going to use delta V and I'm going to use C. I'm going to find the charge here. Once I know the charge here, I'm going to remember that capacitors connected in series have the same charge. So whatever charge I find here is the same charge as here and the same charge as here. If I know these charges, I can find these potentials. That's going to take care of my C3. For my C1 and my C2, remember I've just found my charge and my potential here. And C12 is a parallel connection. These two, C12, C1 and C2, they all have the same potential. That's going to give me the potential, and from the potentials I'm going to be able to find the charge. Okay, that's the overall idea. Let's start working through it. Okay, so let's work through it one step at a time. Step one is let's use our final circuit. Let's find the charge on this equivalent capacitance. So for our final circuit, it has the same potential as the battery, that's 12 volts. For our charge, we know that capacitance is charge divided by potential. So our charge Q is the capacitance times the potential. So that's 1.78 times 10 to the minus 6 farads times our potential of 12 volts. And that gives us a charge of 16 times 10 to the minus 6 coulombs. or 16 microcoulombs. Okay, so for this equivalent capacitance right here, it has a potential of 12 volts and a charge of 16 microcoulombs. I don't quite have room to write that on my diagram, but hopefully the color helps you see that it's all clear. So now we're going to back up a step. This is a series equivalent of these two capacitors. Things in series have the same charge. So now we're going to back up a step. So this charge is on this capacitor, and this charge is on this capacitor because those are a series equivalent. So C3 has a charge Q3 equals the charge we just found equals 16 microcoulombs. The equivalent C12, this equivalent capacitor here between the 1 and 2 before, that has the same amount of charge because this C12 and C3 are in series. So C12 has charge Q12 equals Q equals 16 microcoulombs. For these two capacitors, we know the capacitances. Let's find the potentials. So potential is going to be charge divided by capacitance. So delta V3 is Q3 divided by C3. 16 microcoulombs divided by C3, which was 2 microfarads, gives us 8 volts. Okay, so the potential across capacitor C3 is 8 volts and the charge is 16 volts. Okay, how about C12? It has a charge of 16 microcoulombs. Let's find the potential using the same method. Delta V12 equals Q12 divided by C12. Q12 is 16 microcoulombs. Divide that by 16 microfarads and we get 1 volt. Okay, so now we know the charge and the potential of capacitor C3, and now for C2, we know the charge on C12, Q12 equals 16 microcoulombs, and V12, delta V12, equals 1 volt. Okay, now we back up again. C12 is a parallel equivalent of 1 and 2. Things in parallel have the same potential. That means my potential across capacitor 1 is equal to 1 volt. My potential across capacitor 2 is also 1 volt. So capacitor C1 has a potential delta V1 equal 1 volt. And C2 has a potential delta V2 also equal to 1 volt. All right, we know the potentials and we know the capacitances, so we can find the charge no problem. So Q1 equals C1 times delta V1. C1 is equal to 4 microfarads multiplying by 1 volt to give us 4 microcoulombs, or 4 times 10 to the minus 6 coulombs. For my C2, that's going to have charge Q2 equals C2 times delta V2, which is C2 is 12 microfarads multiplying by 1 volt to give me a charge of 12 microcoulombs. All right, so why don't I even just highlight my answers here. So charge C3 has, capacitor C3 has a charge of 16 microcoulombs and it has a potential of 8 volts. So that's for capacitor 3. For capacitor 1, it has a potential of 1 volt and 4 microcoulombs. Capacitor C2 has a potential of 1 volt and 12 microcoulombs.